Is it audible now, beta?
Yes, sir.
Write the next heading. Block in a lorry. Block in a lorry. Let's say, for example, beta, this is your block, or this is a, for example, a lorry initially. And these are the wheels of this one. And is moving on a road. Okay. It is moving in the front direction where acceleration is not equal to 0. Acceleration is not equal to 0 means the body is having certain acceleration. And on this one, a block is
Yes, sir.
being kept of mass of your M. Okay. So pseudo force will act on this body because it is an accelerating frame. So it is an inertial frame or non-inertial frame?
Sir, it's inertial. It's a non-inertial, sir.
Non-inertial
Sorry,
frame
it's an
because it
inertial
is an
frame.
accelerated frame. So pseudo force
Yes,
will
sir.
act on this one. Pseudo force will be equal to how much for me? M into your A will be acting in the opposite direction. Okay. That means the total block is moving with some acceleration. Mana kada?
Yes, sir.
That acceleration I'm taking it as A dash. Okay. You have to tell me. Now this block is moving in the front direction. The block is moving in the front direction. What are the forces acting on this block beta? On this block of your mass M, one is about your, as it is in motion, obviously there will be a kinetic friction of this one. And pseudo force acting on this body is in this direction, that is M into your A. And acceleration of this block is in the front direction, in the backward direction, that is A dash. Isn't it? So first check the limiting
Yes,
friction
sir.
acting on this one. S limiting is equals to your mu S into your N. So N will be equal to how much beta? This is the weight of the body mg. And this is a normal here right now N. So that will be equal to your mu S into your M into your G. So this is a limiting friction. And kinetic friction will be equal to how much for me? Fk is equals to mu K into your M into your G. Isn't it? So first point. If your force, that is M into your A, is lesser than limiting friction, that means what? Pseudo force is lesser than limiting friction. Then what happens? Can you tell me? Block is at rest,
Yes, sir. Because
isn't it?
friction is
Block
not.
is at rest with respect to lorry. With respect to lorry. So if friction will become how much at a time? Friction is a self-adjusting force. So it will be equal to your M into your E. Ante kada? Because your
Yes, sir.
applied force is not sufficient to break the bond between them. So friction will be equal to your applied force. What is applied force on this one? Pseudo force M into your A. So friction will be self-adjusting. That is the reason it will be equal to your M into your A. So friction on this one will be equal to your M into your A. Okay, na?
Yes, sir.
Now, opposite case of that one, if ME pseudo force is right now. Now tell me this one. If pseudo force, that means M into your A is greater than your limiting friction. So what happened now? The block slides on lorry. The block slides on your lorry, isn't it? So at that time,
Yes, sir.
as it is moving in the front direction, the acceleration pseudo force is in this direction. Kinetic friction is in the backward direction. So that will be equal to mass into acceleration. That is nothing but A dash. Ante kada? To this one.
Yes, sir.
M into your A dash. In this is moving in this direction. Kabatti this force minus frictional force. MA minus FK will be equal to M into your A dash part of relation. Okay, na?
Yes, sir.
Let's see. M A dash, M into your A dash is equals to M into your A minus FK and FK is equals to mu K into your mg. So this one is mu K into your M into G. Is there anything which is getting cancelled better? This
M and M.
gets cancelled. So A dash is equals to A minus of mu k
Mu k,
into
yes.
your g. So this will be the acceleration. Is that clear?
Yes.
So this one is what? Acceleration of the block with respect to lorry. So this one is your acceleration. This is your acceleration of block. Acceleration of block with respect to lorry. With respect to law. ఇప్పుడు చూడు ఒక interesting case. If this is open beta, the end of the trolley, or what you call that one, lorry is open, and if it is moving in the front direction because of the pseudo force, then acceleration in the backward direction ante it will travel this distance and then it will fall down,
Fall down, yes, sir.
isn't it? So time taken for falling down
Yes.
further. So we can calculate the time taken to fall the block. So time taken, if he is asking time taken by the block to fall from lorry. How much? What is the equation I can use? Initial velocity is 0. So S is equals to your u into t plus half into a into your t square. Like say suppose this distance it is traveling is x. Okay. So this is x. Initial velocity is 0. Half. Acceleration will be equal to how much right now? It is a dash. So a dash value is your a minus of mu k into your g into your t square. So from this one, I can calculate the value of your t. So t is equals to how much for me? Under root of your, this one is nothing but 2 into your L divided by your a minus of mu k into your g. So this is the time taken for that body to fall. Okay, now?
Yes, sir.
If he's asking with
So
what
once finished for
velocity
the previous.
will it will fall? Velocity is equals to how much? Velocity with which it falls. Okay, so I can use the relation v is equals to u plus of a into t. Okay, so v is equals to u into acceleration is nothing but if we're equal to how much? This u is equals to how much for me? 0. So it is a plus. So acceleration is nothing but how much for me? This is your a dash. It is a minus of mu k into g into your t, isn't it? So I can even use the relation for the time. Now time value already I know this one. So how much I'll be getting? You see this one. V is equals to your a minus mu k into your g into time.
K,
So time taken is equals to your 2
root
into
over
your
2
L divided by a minus of mu k into your g. ఎంత అవుతుందా?
Sir, like, can we do something like squaring or something?
Yeah, we can take this one inside. If we need to
Yes,
take
sir.
this one inside means we need to do the square for this one,
Yes.
isn't it? So if it goes inside right now, so at that time I can simplify the relation right now. V is equals to 2 into your L part of relation, isn't it? We need to square everywhere, na?
Yes, sir.
Isn't it? So if I'm removing this root right now, or else you take this one into root, you just take this one square and take inside, or doesn't make any difference for me, because if you're taking out of the root again, this will be the same value. So v will be equal to at that time equal to how much for mu? 2 into your L divided by a minus of mu k into your g, because the square of this one will go inside, na beta. One square and this mu
Yes,
k
sir.
will get cancelled. So at the time it will become for me v is equals to under root of your 2L into your a minus of mu k into your g. Okay, na? So this will
Yes,
become
sir.
for me v is equals to under root of your, I can write here 2 into your L into a minus of mu k into your g whole square divided by a minus mu k into your g. This square and this one will get cancelled. So this will be equal to how much better? Under root of your 2L into your a minus of mu k into your g. That will be the velocity. Okay, na?
Yes, sir.
Next one small concept. Insect crawling. Insect crawling in hemispherical ground or in a hemispherical ball. In a hemispherical ball. See, మన దగ్గర ఒక hemispherical ball ఉంది like this. Okay,
There's no chance if it's crawling,
it will slip
it's
and
not that
fall
easy
down
to
every
come
time.
up.
Yeah,
Yes.
it is trying actually. So like say this is your insect right now here. There is your insect right now here like this, and it is a frictionless surface ante complete ga zero. So what is happening is it can crawl for certain distance in upward direction beta. So this is the radius of this one is your radius. Like say for example, insect is been crawling up to this height. Okay, so at this position it is ready to fall down now, isn't it?
Yes.
It is a small
Yes,
part
sir.
but it is easily crawling the up to this part of elevation, and after reaching certain height now it is right now ready to slide down. When it is ready to slide down means what type of friction will be present at a time beta? Limiting friction, isn't it?
Yes,
So we'll
sir.
be getting what? Limiting friction acting on this body. So normal will be in this direction, so normal will be in this direction. So it is ready to move down kabatti friction will be in this direction, that will be equal to F. Ante kada, it is ready to move in the downward direction kabatti opposite to the motion there will be friction. So this is the weight of your mg. If I resolve this one into components right now, see here. Okay, so this one is also your theta. So this will be your mg into your cos theta, and this one will be equal to your mg into your sin theta. This will be crawling down, this will be crawling down because of the force mg into your sin theta. అవునా కదా? అంతే కదా నాన్న? Is the
Yes, sir.
diagram clear?
Yes, sir.
Isn't it? It is ready to move in the downward direction. Okay, what is making this to move down? Mg sin theta kada.
MG sin
So
theta.
in the
Yes, sir.
limiting case, mg sin theta must be equal to what? Frictional force. mg must be equal to your frictional force. అవునా కదా? Now it has been from the ground
Yes, sir.
rise to a certain height beta. చూడు, I'll draw with this one. Is the initial position of your insect. Okay, it has been raised to this much of height. ఈ height కి వెళ్ళిందా? అవునా?
Yes, sir.
So from here to here, what is this one beta? Radius kada. This is r. Everywhere this will be radius only kada,
Yes, sir. Same.
isn't it? So if this is your radius, now can you tell me what is the height in terms of that one beta? So this h will be from here to here. This one is nothing but equal to your r. So if I resolve it, here this will become for me r cos theta, and here this will become for me r into your sin theta. So from here to here, initially it is how much beta? From here to here, initially it is nothing but r. From here to here, initially it is your capital R, and from here to here, this component if I'm taking right now, this is right now for me r cos theta. So h రావాలంటే ఏం చేయాలి మనం? h will be equal to your r minus r cos theta. అంతే కదా? ఇక్కడ నుంచి ఇక్కడ వరకు r cos theta, ఇక్కడ నుంచి ఇక్కడ
Yes,
వరకు
sir.
capital R, isn't it? So r
So,
minus
yes,
r
sir.
cos
R
theta will
minus.
give me the height. So r is your common into 1 minus of your cos theta. So this is the height to which it is raised. ఒకవేళ height అడుగు. Okay na?
Yes, sir.
Now
Yes,
mg
sir.
is equal to how much for me? Limiting friction. So this mg is equals to limiting friction is nothing but mu of your friction, that is nothing but static, and into your normal. Now this normal is equals to how much beta? See from the figure, n is equals to your mg into your cos theta, isn't it? So this will become for me mg is equals to mu into s, n is equals to mg into your cos theta. So this mg and this mg will be getting cancelled from that one. So what I'll be getting, can you tell me right now? Something else is also getting. Why mg beta? Mg sin theta kada idi. Sorry.
Yes, sir.
చెప్పవే. This will be equal to your mg into your sin theta. So I'm writing here mg into your sin theta will be equal to limiting friction, and n will be equal to mg cos theta. So this will be mg into sin theta is equals to mu s into n. N will be equal to mg into your cos theta. So this is nothing but
Cos theta.
equal to mu s into your n. Okay, so this mg
Yes.
gets cancelled. So sine by cos, here it is nothing but sine theta, and this is
Tan is
nothing but cos
tan theta
theta
is equals
is
to
equals to mu s. So that means mu s will be equal to your tan theta. It is
tan
something
theta.
like of your angle of your friction.
Yes,
అవునా
sir.
కదా? Angle of friction, angle of repose is equal to how much only? Mu s into your tan theta part of your relation. So mu s is equals to your tan
Yes.
theta. That means if I'm writing the tan theta value in terms of your trigonometry, isn't it? So mu s is nothing. Tan theta is nothing but mu s by 1. Ante here its side it will become for me mu s. This will become for me 1. And this will become for me mu s square plus 1 square
Plus
is 1.
one.
This one is theta.
Yes.
అంతే కదా tan theta.
Opposite. Yes, sir. Opposite by
Just
adjacent.
divided by 1 కదా.
Yes, sir. Opposite by adjacent.
Yeah. So I can write from this one
Yes,
cos
sir.
theta is how much from this one? Cos theta
Cos
is
theta
equal
is
to
one
cos
by
theta value will
one
be
by
equal to
root over one
yeah
by root over
yeah
mu s
1
whole
by
square plus one.
root over mu s square
Mu s square plus
plus 1.
one.
అంతే కదా? This one.
Yes.
Isn't it? So
Adjacent
from this
one.
one you see I can write the relation here r minus of your h, isn't it? R minus of your h will be equal to how much right now? ఇక్కడ నుంచి ఇక్కడ వరకు ఈ వాల్యూ ఎంత అవుతుందన్న? R minus h అని రాసుకున్నాం. Total R.
Yes,
This
sir.
is
And
your
r
R.
cos,
This can
and we can
also be
write
written
r
as
by
of your R minus of your h, isn't
yes,
it? So cos theta will be equal to how much better? Cos theta is also equal to your R minus h divided by your R. అంతేనా? Sorry.
yes, sir.
See the diagram. This is your R cos theta is nothing but R minus h only, na? And this one is nothing but of
Yes,
your
sir.
total R, isn't it? So if I'm
Yes,
writing
sir.
from here
So
to here, this one is R, this one is R minus H. So I can write cos theta
yes,
is
sir.
also equal to R minus of your H. Or else I can write this one as of your 1 minus of H by R. అంతేనా?
Yes, sir. Yes,
So
sir.
H is equals ఎంత వస్తుంది
Then we
మనకి? ఇట్లా
can do
చేసినా కూడా ఎంత వస్తుంది? H is equals to your R into 1 minus of cos theta. Is that clear?
yes,
This already I
yes,
told
sir.
you here itself initially. H is equals to
Yes,
R
sir. Yes,
into
sir.
1 minus of your cos theta.
One
Whichever
minus
you feel
cos.
comfortable,
Yes, sir.
you can use that relation and calculate the height. So if you need to calculate the height
Yes, sir.
right now, so that H will be equal to your R into 1 minus cos theta value already I got. So it is under root of your mu s square plus of your 1. So this will be the height H. Okay, na?
Yes, sir. Yes, sir.
I hope you got an idea right now related to that one. Okay, na?
Yes, sir.
Sure. Let's try to do some problems better. నేను
Sir, is
నీకు
it
నేను మంచి
very
ప్రాబ్లమ్స్
fog?
పంపించాను. ఎస్ నాన్న.
Yes, sir. Ninna, I'll do it today, sir. Okay, Ninna, I didn't get time, sir.
You try to complete it today better if you are getting the time basically. Whenever you get the time,
Yes,
please try to complete that. Okay, na?
yes, sir. Sir, is it foggy near your house, sir?
Is better?
Is it foggy near your house?
No, actually. Why?
It's very foggy at like around Ratchaburi.
No, it is completely okay with us here. So, should I do some problems better?
Yes, sir.
See this question better. The system consists of three masses. M1, M2, and M3 connected by a string. Passing over a pulley. P. Stop. The mass the mass m1, the mass m1 hangs freely, and m2 and m3, are on a rough horizontal, table, So friction between them is, say for example, mu. Okay, the pulley is frictionless and negligible mass beta. The downward acceleration of mass m1 is, the downward acceleration of the mass is, just a minute beta, give a minute time.
Yes.
Today, the system consists of
Yes.
your masses, three masses m1, m2, and m3 connected by a string passing over a pulley. The mass m1 hangs freely and m2, m3 are on a rough horizontal table. The downward acceleration of mass m1 is, the downward acceleration of mass m1 is, the system is given something like this. Here there is a pulley, and here there are the blocks right now which have been connected, and here is one more block which is hanging in the downward direction, and this is your rough surface beta. On a rough surface, the total coefficient of friction is mu everywhere. Okay, and the blocks are given the masses right now. The one which is hanging, this is your m1, this one is right now your m2, and this mass is, say for example, of your m3, and this is a pulley p. Now try to do it out better. Make an FBD clearly and try to apply. In which direction the pulley is having ability to move better? In a downward direction kada. So this is trying to move
Yes,
in
sir.
the downward direction with acceleration a. So total system will also will move with the same acceleration, isn't it?
Yes, sir.
So when it is moving in this direction, frictional force will be acting on this body in this direction better. The in pen of
Opposite, left.
friction, both the
Yes.
frictions are acting in the opposite direction. So body is moving
Yes,
the
sir.
downward direction.
This is,
But the weight వచ్చేసి mg in the downward direction. Second, right here mg
yes, sir.
minus mu times of u1. So the weights of the body is how much right now? Downward acceleration of mass m1. The system consists of your three masses m1, m2, m3 connected by your pulley. Ante this one is nothing but of your m1 into your g minus mu into your, this one is nothing but of your m2 into g minus, this will be equal to how much better? Mu into your m3 into your g
M3 into
is
it.
equals to your m1 plus m2 plus m3 ana kada, m1 plus m2
Yes, sir.
plus m3 into common acceleration, that is nothing but of your a. Okay, so is this
Yes,
anything
sir.
getting common in this one better? G I can take it as a common in this one, isn't it?
Yes, sir.
So this one is G common. So it is your M1 minus mu into your M2 minus
M2.
mu into your M3 is equals to, this one is your M1 plus M2 plus M3 into your acceleration A. So if you simplify it, acceleration will become for me A is equals to G into, this one is M1 minus mu into your M2 minus mu into your M3 divided by M1 plus M2 plus M3. Okay now,
Yes.
clear? Huh? So
Yes.
this will be the acceleration. I hope you got it.
Yes, sir.
So, take one more question later. It's a good question. You try to do it out. pen and paper isko, I'll give some time. Just make an FBD clearly. A block capital A of mass 200 kg rest on a block capital B of mass 300 kg First stop. A is tied with a horizontal string to a wall coefficient of friction between A and B is 0.25, and that between B and floor is 0.2. Okay, the horizontal force capital F needed to move the block B is so this is a given diagram like this. This is your system. So here we are having a 300 kg block, and on this one we are having a 200 kg block, and you are applying the force in the downward direction F, and upper block is connected by the string like this. Okay, so options are given for me. 550 Newton, second option is 1002 Newton, third one is 1500 Newton, and fourth option is 2200 Newton. Should read the question carefully first. A block A of mass, how much beta? A is given, but means this one is your A.
kg.
Yeah, 200 kg. This is your A. And block B, this is your block B of 300 kg. A is tied to the horizontal string to a wall. Coefficient of friction between A and B, and ikkada. Here the coefficient of friction is 0.25, and that between the B and ground, that means here it is 0.2. The horizontal force needed to move the block will be equal to your how much? So just first draw the independently the FBD beta. Break the system and try to draw the FBD. I just have 2 minutes time this.
Yes, sir. Sir, so 200 kg. Sir, so there's force from the string also, no, sir?
Yeah, there is a force due to your string also. But it is not moving. See, if you are making this diagram like this, that is very important for me. So here, when you are making, this is 200 kg, and down there is one more block. This one is how much for me? 300 kg. You are applying the force on this one, capital F. So obviously friction develops on this one in this direction. So this is your friction F1. And ikkada kuda oka tension develop avutundi, that one is T, and there is equal and opposite friction on this one. This is your F1. Because this is force, deenki opposite force here right now friction is in the front direction. This is important, right? This is your F2. Because the string, if it is pulling here, this exerting the friction on this one. So if Newton's third law, this two will be exerting opposite. Now when you are applying this force, so here the friction was supposed to be in backward direction, but because of this one to be more, because of that one, this F2 is acting in the front direction. So right now, if I write the equation, this T must be equal to your F1.
Yes, sir.
Isn't it? The T must be equal to your F1. So F1 will be equal to how much? Can you tell me? F1 is equals to your mu value is 0.25 into this one is of your 200 G. 200 G means that will become for me 2000. F1 is equals to mu1 into your 200 into G. Weight of this body is your 200 G, and here it is your normal, say for example N1. Okay. Now on this one there is a
Yes.
normal, that is nothing but of your n2. దీని నార్మల్ కూడా దీనిపైన యాక్ట్ అవుతుందా? దట్ ఈస్ నథింగ్ బట్ ఆఫ్ యువర్ n1 in the downward direction, and weight of this body is
Yes.
nothing but 300 in the downward direction.
300.
So what is the
Yes.
value of your f2? F2 will be equal to your f2 is equals to your mu. Say
0.2
here the right
into
now the coefficient of friction is mu2. So this one will be equal to how much weight
0.2,
is this?
sir.
F2. Yeah, yeah,
Mu2 is
0.2.
0.2.
Yeah. See, this n1 is acting in the downward direction, isn't it? So f2 is equal to how much for me? Mu into your n1 plus of your n2 part of relation. This n2 will be equal to how much you see right now? Vertical forces right now. What are the vertical forces acting on this block? So one is nothing but of your n2. That is nothing but of your n1 plus this one is nothing but of your 300 g in the downward direction. అంతే కదా? See,
Yes.
on 300 kg, 300 g in the downward direction. This one is exerting the normal in the downward direction, that is n2, and this n2 is in the upward direction. So this n2 will be equal to n1 plus 300 g. n1 is equal to how much for me? 200 g plus of your 300 g. And that will become for me your 500 g. Antena? So it is your 500 into your g. Mu value is given how much? 0.2. So this one is your 500 into g value is nothing but 10. E10 e 0.2 వెళ్ళిపోతుంది కాబట్టి this will come for me how much for me? 1000 Newton. So total force will be equal to how much right now? Capital F will be equal to your how much right now? See. So capital F will be equal to your how much? Can you tell me right now? This F1 and this F2. Both of them are acting in the front direction. So it should be equal to your F1 plus of your F2. F1 is equals to how much for me? F1 how much you got to do? ఇది క్యాలిక్యులేట్ చేయి.
So 500 వస్తుంది.
0.220 వెళ్ళిపోతుందంటే this will become for me
500
500.
వస్తుంది.
So this will be your 500 plus this one is nothing but of your 1000. So that will be equal to your 1500 Newton. Okay now?
Yes, sir.
It was about your condition.
Sir?
So this is very important. But it is very important. Whenever there is a string right now and you're pulling in this one, you first need to take the friction between 200 and 300. Then you try to take the friction depending upon that given, because this body is not moving kabatti. Every time this friction is in this direction, because of that one frictional force acting on this body is in the small f, and on this body this one is of yours another one, and on this one is capital F. Now here the friction was supposed to act in the backward direction, but it is more kabatti, so the kinetic friction will be acting in the front direction if it is
Yes.
in the motion.
Sir,
But
can
it is
you
just
once
ready to move
explain?
kabatti, F will be equal to F1. Yes beta?
Sir, can you once explain the normal forces? This right
This
side
normal
of
force you see right now, this one is your n1 here. Weight of the body is your
Yes.
200 into g, isn't it? Now
Yes.
on the 300 kg you see right now, on the 300 kg, one is normal in the upward direction. Weight of the body
Yes.
300 g in the downward direction, and the normal of this one is
Yes,
also
sir.
in the downward direction, isn't it?
Okay, yes,
So
sir.
this
Got it,
n1
sir.
is
So
in
we
the
have to do
downward,
N2 minus N1.
300 g in the downward. This is your n2.
Yes, sir. So we have to do like for the 300 kg one, we have to do N2 minus N1 is equals to 300 G. So you just took the N on
Yeah.
this side and okay, sir.
Or else you can take this 200 and 300 also acting in downward direction. That must be equal to n2.
Yes, sir.
n2 is nothing but only 200 kada.
Yes, sir. N1
Okay, na?
is 200.
This n1 is your
Yes,
200 g. If 200 g is
200,
exerting the
yes.
force on 300 g downward,
Yes, sir.
this 300 g is also in the downward direction. So 200 and 300 are in the downward direction. So it is 500 g. And this n2 is in the upward direction. అర్థం కాలేదా?
Got it, sir.
Okay.
Yes, sir.
Sure. I'll stop and restart it once again.
Yes, sir. Okay, sir.
My rejoin.
Yes.